Hello, everyone. Welcome again to our series on PyTorch. And as I said in my previous video, we are going to be working with PyTorch, but we're also going to be using ChatGPT to generate the code, and then we will analyze the code and also run the code with Google Colab. ChatGPT, it's very useful in generating code very quickly instead of typing and writing the code ourselves. And as we use ChatGPT, we are gonna ask some questions to ChatGPT about about almost every line of the code, and then that will help us try to understand PyTorch, and also will help us try to understand the code at a very basic level. So I think it's very useful. ChatGPT is, in the sense that even though some answers may not be correct, it can give us a little bit of a framework to work with, and that's why I think it's very useful, and it's likely the future of trying to learn coding, and also by extension it's also the future of learning. It seems like it. And essentially we have to embrace the future. And to work with ChatGPT, you have to understand a little bit of the code. And as I said in my previous video, with coding now, sometimes I think programmers are going to be more geared towards trying to debug the code which has been generated by ChatGPT or ChatGPTs of the world, like these large language models. So without much ado, we will go ahead and get started. And I will go to my browser. I'll go and open my browser here. I've been using Google Chrome. And once I open my browser, I will come here and I will be able to open ChatGPT. So I'll open ChatGPT like that, and I have the paid plan for the ChatGPT, but you can also use the free plan. And I actually find sometimes the free plan is a little bit quicker for some reason than the paid plan, but that's a debate for another day. So without much ado, we wanted today to talk about PyTorch, introduction to PyTorch, and more specifically, we wanted to see about a neural network. We want to understand what is a neural network, which is essentially, as we saw in my previous video, it's the one that we are going to be using for machine learning. Machine learning with PyTorch, it's all based on neural networks, and we saw the different neural networks yesterday. And today we're just going to see how we can be able to maybe use ChatGPT to write a code for us for a simple neural network, and then we'll try to analyze that neural network with a ChatGPT. And in other videos, we'll be able to go to Google Colab and run the code that the neural network generates for us. So without much ado, what I will do is that I will go ahead and open and actually type a prompt to ChatGPT to maybe tell me how to create a simple neural network for Python. So I will type create simple neural network for PyTorch. and I'll just press on enter like that. And ChatGPT, I think it's quicker now, so that's good. And it's gonna tell me creating a simple neural network in PyTorch is a great way to introduce the basics of neural networks. And then it says here is a straightforward example of small feed-forward neural network. Remember we said yesterday, we said the feed-forward neural networks are the easiest neural networks to create, and they are the basic they are the basic neural network in the sense that they introduce us to learning about neural networks, and also uh, impart into us the knowledge, the basic knowledge that we need, so we can grow from that knowledge as we continue building even more complex neural networks. So it says here, here is a simple neural network, is a simple example of a small feed-forward neural network that can be used for binary classification tasks. Binary is where you have, binary means two, you have two classes. You have a class of a cat and a dog. You're trying to classify a cat and a dog, or you are trying to classify different objects in two different classes. But that's the binary classification task, such as distinguishing between two types of objects. So I find the way ChatGPT explains is easier to understand, and even if it gives you something that's a little bit complicated, you can always be able to tell it to explain to you in a little bit more simpler way, or you can tell it to explain to you as if it was explaining to a 5-year-old, and in that way it can actually provide for you a little bit of more simple explanation, so that you can be able to understand at the basic level. And once you understand that way, especially in complicated things like neural networks and the different aspects of neural networks, then that understanding is going to stick with you for a long time, because you understood it at a very basic level. And then you can understand the simple explanation, then you can build on that. And that's the beauty of learning. That's the beauty of learning, not just programming, but anything truly with ChatGPT or the other large language models for that matter. So here, ChatGPT says to create a simple neural network. This is a feed-forward neural network, remember. It says the first thing that you need to do is to import the necessary libraries. And first, you'll need to import necessary modules from PyTorch. So first thing is that we import PyTorch, and then we import torch.nn as nn, and then we import torch.optim as optim. And then after that, that's step 1. And step 2, ChatGPT says, step 2 is to define the neural network. And it says for simplicity, this network will have one hidden layer. Remember when we had our neural networks, and this is the feed-forward neural network, we had the input layer, then we had some hidden layers, and then we had the output layer. So here, ChatGPT is telling us the first thing that we need to do for the network is to define an hidden layer. We can define one hidden layer. We can have 20 hidden layers. We can have 15. The number of hidden layers is as much as you want. And ChatGPT is saying we are going to use nn dot sequential module. We're going to use nn dot sequential module to stack the layers. And here we have a simple definition of the neural network. So we have the neural network that ChatGPT wrote for us is the class is called SimpleNet. and that utilizes the nn dot module uh, and then we define the init method. This one is to the init method is the one that gets run once we create the simple net network. So we define the def underscore underscore init, and then we pass in self, and then we call super simple net, and then we also pass in self and we init. And then we have the self.network, nn.sequential, and all that. So this is good. Then we have one linear layer is nn.linear, and this is the input layer with 10 features, outputs to which outputs to hidden layer with 5 nodes. Remember the features and the nodes that we saw, and this is going to send this to to a hidden layer with 5 nodes, and it's going to have 10 features. We will see this. Actually, as a matter of fact, we'll ask ChatGPT to explain to us every single line, so we can have a good understanding. And then we have another activation. We have an activation function here, and it's nn.relu, relu activation function. Then we also have hidden layer with 5 nodes and 1 output node. And that's our hidden layer there. And you can see we passed in 5 and we take in 5, which is also very important. And then we call the activation function for output layer, and this one we are using the nn.sigmoid, and nn.sigmoid is for binary classification. We will ask ChatGPT a series of questions to try to explain to us what we just have in this code here. And then we have the forward function, and the forward function takes in self and x and returns self dot network and passes in the x. So we will be able to ask ChatGPT to explain to us all this, and that way we can be able to learn together. And that's why I find it to be very helpful to learn how to program, or rather how to write code while utilizing these large language models like ChatGPT. And then it says that step 3 would be to instantiate the model and define a loss function and an optimizer. We'll see what these are. We'll learn this with ChatGPT. So when we start getting our code and going to Google Colab, we can be able to understand what every line in this code does. And so here you create an instance of your model. Remember, the model that we have created is this model here, the SimpleNet. So we create an instance of your model, choose a loss function, binary cross entry, because we have binary, our output layer is binary. We are outputting binary, 2 things, like 2 objects, either a cat or a dog. We have in our model tell us, is this a cat? This picture I'm presenting you, is it of a cat or is it of a dog? And that's where the binary aspect comes in. So here we're going to create an instance of a model. We are going to choose a loss function, which for this ChatGPT says we can use binary cross entropy, in this case for binary classification, and then select an optimizer. So we have our model, we are building an instance of our model. So this code creates an instance of a model, and our model, we've created the model here, SimpleNet, and then we use the criterion binary cross entropy is nn dot binary cross entropy loss. That's our loss function. And so binary cross entropy laws, and then we have our optimizer here. We are choose our optimizer here, and we are choosing the Adam optimizer, and we pass in the model parameters, and we also pass in a learning rate of 0.01. But we'll be able to see this as we continue with working with ChatGPT. We'll ask ChatGPT to explain each and every line and also what that line does. And I think that's a good way of trying to get a basic understanding of what we are doing of our neural network, so we can see what each line is doing, and then we can go on from there. So here ChatGPT does say that the Adam optimizer with a learning rate of 0.01, as we said. And then we come here to step 4, where it's going to be training the model. We will see that a little bit later on. I actually want us to just concentrate for now on step 1 and 2, and then we can ask the ChatGPT what each line does. And we can start with just the basic, the ones that we know, just for introduction, so we can all be able to be on the same page. So I'm going to ask ChatGPT, what does import torch do? So I've just come here, what does import torch do, like that. And then I'll press on enter, and then it's going to give me a basic understanding and on that line alone. And it's going to introduce some other things. Some of them will go a little bit deeper, but for the most part, we'll just be able to kind of like peruse over them, because we may not be ready to talk about them at this point. And also we may have ample time and right time to talk or to talk about them. But for now, ChatGPT says the command import torch in Python is used to load the Python library into your Python script, making its functionalities available for you to use. PyTorch is an open source machine learning library developed by Facebook. We already know that. Widely used in applications such as computer vision and natural language processing. And so the most important thing to get from here is that the command import PyTorch in Python is used to load the Python library into your the PyTorch library into your Python script. That's the basic. And what that does is that it makes the functionalities of PyTorch available for you to use. And then here, ChatGPT says here is a breakdown of what import torch enables: tensors, autograd, neural network models, and this is one we're dealing with. So it says neural network models. I think that's a little bit relevant for us here. So it says through torch.nn, PyTorch provides many pre-built layers and utility functions to construct and train neural networks. That's another reason we're importing the PyTorch module. Import PyTorch gives access to these foundational components, such as linear layers like nn.linear that we have seen, activation functions like nn.relu, the one that we have seen in our neural network, and also the loss function nn.binary cross entropy loss, BCE loss. And also optimizer. We have seen the optimizer in our model here. We see the optimizer here that we were choosing, and that is provided once we import the PyTorch model. It says PyTorch offers several optimization algorithms for training, such as SGD, Adam, and RMS prop, accessible via the torch.optim. These are used to update the weights of the network based on the gradients computed during backpropagation. We will see backpropagation, and we'll also see about weights and biases as we continue with our PyTorch series. But for now, I just wanted to kind of like go line over line and see why we are doing what we are doing when we are importing PyTorch. Utilities, and also per ChatGPT, PyTorch includes various utilities for data handling like data loaders and transformers in torch.utils data model saving and loading, model saving and loading, and other helpful utilities that facilitate machine learning experiments. And also device management. It says the NN, the PyTorch library that we are importing, the library provides functions for managing computation devices. This includes support for CPU, GPU, and more recently, TPU computations. You can use torch.cuda. We'll see that actually a lot when we are working, building our models in the Google Colab. But you can use torch.cuda to manage GPU operations specifically. So essentially, by importing ChatGPT, you essentially unlock the potential to use all these features and functionalities within your PyTorch script, allowing you to develop and train sophisticated machine learning models efficiently. So that's pretty much good. It gives you a little bit of why are we doing this, and it gives you a basic understanding of why we are doing that. And I really think that's very helpful. It's also a very helpful way. It's a very helpful way to learn. So we can also do the same thing, and we can ask ChatGPT why we are importing the torch.nn. Why are we importing the torch.nn module? I just said, why are we import torch.nn as nn? And again, very beautiful. I just think this way of learning, it brings the basic understanding to the fore. And I think that's very helpful. So the statement import torch.nn as nn in PyTorch is used specifically to import the neural network module from the PyTorch library and alliances it as nn for convenience and readability. So it imports the module and then it gives it the name nn, so we can be able to, instead of typing all the time the whole thing torch.nn, we can just type nn, and that makes it more convenient to use and also easier to read in the code. So the torch.nn module is one of the foundational components of PyTorch, providing the necessary classes and functions to build neural networks. And then it gives us a list of why it's important, why the torch.nn module is important, and why it's commonly imported. And then it gives us layers types. The torch.nn module includes a variety of layer types that are commonly used in constructing neural networks, such as linear layers. We see nn.linear, that's torch.nn.linear. These are fully connected layers that linearly transform input features into outputs. If you don't know the input features, remember when we had our neural networks, we had the input, then we had the hidden layers, then we had the output layer. We had the input layer, hidden layers or layer, and then we had the output layers. So it says that the nn.linear is they are fully connected layers that linearly means line, linearly transform input features into outputs. And then another reason why the NN module, another layer type that is imported with is found with the NN module is the convolutional layers. And convolutional layers, the nn.conv2d, these are vital for processing image data, and these layers apply to convolutional operations that are capable of spatial hierarchies in data. We will see this a little bit later when we learn about convolutional neural networks, but right now, since we are learning about the feed-forward neural network, I think we've been using the linear, the nn.linear, and also we have the recurrent layers, and these are the ones that we use with recurrent neural networks. We'll talk about that later, but ChatGPT does give you a breakdown of different ways that this module, the NN module, the different layers that you can be able to use once you import the NN, the NN module, the torch.nn module, which we have given an alias of NN, because when we were here, we said import torch.nn as NN. So now we are calling torch.nn NN. So I think you get the concept. When you say import something as something else, you are saying import that. And in my program, when I write my program, what I have imported, I'm going to be referring to it as that, what the name that I gave it. This can be NN or it can be any name. This can be our layers. It can be, you can call it a cat for all intents and purposes. It doesn't have to be NN, but for conventional purposes and also to his readability, most of the time we import it as NN. But right now, so when we talk about NN down, we are referring to this torch.nn module. And so that's that. And then we will see, so here we said, the torch.nn module is one of the foundational components of PyTorch, providing the necessary classes and functions to build neural networks. And then here are why it's important. Here is why it's important and commonly imported. One reason is that we have layer types. We can be able to access different layer types, and also activation functions. We can be able to, by importing the torch.nn module, we can be able to also gain access to the activation functions. And activation functions like ReLU, nn.ReLU, sigmoid, nn.sigmoid, and tar, nn.tar, T-A-N-H, nn.tar, are essential for introducing non-linearities to the network. Non-linearities, something that's not, it's non-linear, not a straight line. Non-linearities. So non-linearities into the network, allowing it to learn more complex patterns. Remember, the point of the neural network is to learn patterns, and once we use ReLU or sigmoid or other activation functions, then we can be able to allow our neural network to learn more complex patterns that are nonlinear, that may be able to, because we introduce non-linearities into the network, so the network can be able to learn more complex patterns. non-linearities. Very important. Non-linearities, the way to think about it is non-linear. Linear, think of it as a line. So non-linear, so a straight line, a linear straight line. And when you have a circle, it's not linear, it's non-linear, and then that's why you can have your neural network learn more complex patterns, like patterns that are more circular or that are non-linear. And then also another thing is that we have the loss function, and the nn dot module torch.nn, which we imported as nn, provides several loss functions which are crucial for training neural networks by comparing the predicted outputs with the actual targets. Common examples include nn dot mse loss for regression tasks and nn dot cross entropy loss for classification tasks, the one that we have seen. And then utilities. So you can see that I won't really go through all of it, but I just wanted to show you the importance of importing the torch.nn module when we are building our neural networks. And I find ChatGPT very helpful in giving us a breakdown. And so ChatGPT says importing NN using import torch.nn as NN allows developers to utilize all these tools, the ones that we have seen here, layer types, activation functions, loss functions, utilities, like nn.sequential regularizations, and also parameter management. It allows developers to utilize all these tools directly with a simple NN prefix, enhancing code clarity and reducing the likelihood of naming conflicts with other libraries or variables. This way of importing and using PyTorch neural network functionalities is standard practice in the community due to its efficiency and ease of use. And what ChatGPT is saying there is why we have to import it as NN. So we can be able to at least not have name conflicts, and also it can ease with readability. And in the same token, we will ask ChatGPT what import torch.optim does, and we'll just come here and we'll ask ChatGPT what does do. So, and then we'll see what the answer that we get. And here ChatGPT says the statement import torch.optim as optim. Again, you see the S, because we are saying we are gonna import this, and when we write it on the code, we just want to simply write it as optim for easy in writing code and also to enhance code readability. And so when we refer to optim, we are going to be referencing to torch.optim, but the statement import torch.optim as optim in Python is used to import the optimization module from the PyTorch library and alliances it as optim, or rather give it the name optim. And this doesn't have to be optim, as we've seen. It can be anything. It's just that it makes the code a little bit more clear when you import it and you call it as optim, because people who are reading your code, or even you, when you come back later to read your code, you can easily note what this is, because you can easily deduce what it is, because optim, and we're importing torch.optim, so the name is very much more clear and you can easily understand your code later on that way. So the torch.optim is crucial for training neural network, as it provides various optimization algorithms that can be used to update the weights of the network based on the computed gradients. So we'll talk more about computed gradients. We'll also talk more about weights and biases, as we have seen, as we continue learning PyTorch and neural networks. So a little bit of a breakdown of key functionalities of import torch.optim and also why it's important. Number one, optimization algorithms. Torch.optim includes a range of optimization algorithms that are essential for training machine learning models. Some of the popular optimizers available in this module include SGD. This is also abbreviation for stochastic gradient descent, and what this is a simple yet effective optimization method often used with momentum and weight decay enhancements. And we will actually use this as we go and as we continue with PyTorch. And also another optimizer is the ADAM optimizer, and ADAM stands for adaptive moment estimation. And what this does is that it combines the advantages of two other extensions of stochastic gradient descent, namely RMS prop and momentum, and is generally regarded as being fairly robust to different settings of its hyperparameters. We'll see about hyperparameters too as we continue with our journey, but I just want to give you just a little bit of a breakdown so we can have a little bit of an overall picture. And then we also have another optimizer called RMS prop, and this maintains a moving average of the square of the gradients and divides the gradient by the root of this average. And we'll see about gradients again as we go. And then another optimizer is undercard, ADAM, W, under delta, and more. But that's about it. I think that gives us a little bit of understanding. And another key functionalities of the NN of the torch.optim module is that it also gives us a way to be able to have a learning rate scheduling. And the torch.optim module also includes utilities to adjust the learning rate during training, which can help improve model training and conventions. Learning rate schedules like torch.optim.lr underscore scheduler dot step lr, torch.optim.lr underscore scheduler exponential lr, and others allow dynamic adjustment of learning rates based on training epoch or other criteria. And we'll see the training epochs as we go. It's when we talk about training a neural network. But for now, just want you to understand the concept of learning rate and the fact that torch.optim provides us, that module provides us a way to be able to define the learning rate. And also another reason why we need the torch.optim module is for parameter management. Optimizers in the torch.optim models are designed to work directly with the parameters of the torch.nn module. You typically initialize an optimizer by passing the parameters of the model accessed via model.parameters along with specific hyperparameters like learning rate. And then it gives us a little bit of an example. So it says the import and usage of Optim, or rather import and usage of Optim, that's the torch.optim, are essential practices in PyTorch for implementing the optimization step in the training loop. We'll see the training loop, allowing you to effectively minimize the loss function of your models. The alias optim instead of torch.optim makes it straightforward to access these optimizers and manage their behavior throughout the training process. I think that's a good way of explanation and a good way to understand the basics. And then we could do the same thing here. We can, maybe we know we are instantiating. Here we are defining the model. We are defining the neural network model, and we're using the class.simplenet. So if we want, we can maybe ask again, we can ask ChatGPT, what does this line do? And see what it says. What does this do? And we learn like that, and we'll see. So we have the code snippet here, and the code snippet that we have is we are in this area now. We are trying to define the neural network, and we want to understand what this class simplenet and then nn.module does, and we have ChatGPT, and what ChatGPT says is we can see. So the code snippet sets up and uses an optimizer for training a neural network in PyTorch. So I think it's talking about, so importing the optimizer, we import the optimizer NN. I think it's actually giving us a little bit of not what we asked for. And maybe I typed, I did not provide, this is the reason. I did not provide, I just said, what does this do, but I did not paste. I wanted to paste this, the class, so my fault there. It gave us information about optimizers, but we wanted to see what this class, simplenet, and then parentheses nn.module, what does that do? That's what I meant. So just go ahead and ask it again, what does this do? And I'll just type that. And there we go. So we are back in action, and it says the class simplenet.nn module is a declaration of a custom neural network class in PyTorch, which defines the architecture of the neural network. The class defines the class simplenet, and then parentheses nn.module. It defines the architecture of the neural network. That's very important. Defines the architecture of the neural network. This class inherits from the nn.modules. That's why we have it. We have the nn.module right there. So we define the class. It's we say class simplenet, and then it inherits. So we put the module it inherits from. We put it in parentheses. So this class inherits from the nn.module, which is the base class for all neural network modules in PyTorch. That's very important. So we inherit from this nn.module, which is the base class for all neural network modules in PyTorch. So it's very important to understand, and there you have it. we have the class, we define the class name, and we also define it as a class, and we say this class, SimpleNet, inherits from the nn.module, and this nn.module class is the base class for all neural network modules in PyTorch, and we can break what this declaration of this class involves and why it's significant. And then we start with the base class, the nn.module. That's the base class, as we have seen. And we say inheritance from the nn.module. So by inheriting from nn.module, SimpleNet, the class that we have, gains all functionality of PyTorch module classes, which includes managing parameters, moving them to different devices, loading or saving modules, and more. This inheritance, this one, nn.module, that's where we are inheriting. So this inheritance is crucial for integrating seamlessly with other PyTorch functionalities like optimizers and training loops. So, and then we can talk about definition of the class. We define the class SimpleNet, class name. SimpleNet is the name of the class. It is a user-defined name that describes the network. The name is typically indicative of the network simplicity or purpose. So we don't have to call it SimpleNet, like when we defined our class here. We don't have to call it. Let's go where we defined our class. When we defined our class here, we don't have to call it SimpleNet. You know, SimpleNet is just a name that helps with simplicity, or it also helps to define, kind of like try to let someone know what's the purpose of this class. So SimpleNet is just an arbitrary name. You can call it class dogs or cards or class, you can give it any name that you want. It doesn't have to be SimpleNet. And then we're gonna go next to where we were. And so we saw that the class SimpleNet is the name of the class. It is a user-defined name that describes the network. The name is typically indicative of the network's simplicity or purpose. Initialization method, we have the init. So I think it went a little bit to actually define the all thing, and that's fine. I think that's a good way to look at it too. And I want to see if I can make a way that we can be able to, instead of scrolling up and down, maybe we can get this code, and maybe we can just open another tab here, and we can also go back to ChatGPT, and I can just type this code here, and I will just run the code so I can have. So once we have that, we can be able to maybe a reference to it. And I wanted this to actually be written in I wanted this to be written in a code format, in a code box. Can you write? I'm gonna just write this in a code format. Let's see if it does. I just want it to see. Okay, I wanted something like that. So instead of us scrolling up and down, we can just go to this tab, and then we can be able to see what we are talking from there. So I think that's easier. I think it's also easier to follow. So we can go to where we were here, where we have the class SimpleNet. And so we talked about the base class nn.module, and the base class, which is our SimpleNet base class, and we saw that it inherits from base class nn.module. As you can see here, this line here says this class SimpleNet inherits from the nn.module, and so that's where we are. And next we were talking about the initialization method, and this is a special method. It's __ init __, and it's the one that they provide here. It's also the one that you can see here, this initialization method here, the def __ init __, and it takes in self, and this is what we are talking about. So the initialization method, this method is where you define all the layers and components of the networks. In neural network, you would typically set up layers like convolution layers or linear layers or dropout layers, batch normalization layers, etc. And this is this init method is the special method that you use to initialize those layers. You typically set up the layers. So that's where you typically set up the layers in the init, in this special method, def __ init __ self. I still wanted ChatGPT to be a little bit more detailed on this init method, and what I'll do is that I'll just go ahead and copy this, and I will ask ChatGPT to be a little bit more explain more on that, on this special method init.self. And this is how you learn with ChatGPT. You can ask it to dig deeper and deeper, as you can see. And now it now talks about the init method, and it said the init method is a special method in Python, as we have seen, often referred to as a constructor. And it is automatically called when a new object of a class is instantiated. So this is the special method __ init, and it's normally called a constructor method, and it is automatically called when a new object of that class is instantiated. So when we instantiate a new object of our class here, SimpleNet, this special method, the init method, is automatically called. It's a special method automatically called once we create an instance of the class where that init method is. And in this case, that class is the SimpleNet class. So this method is crucial in object-oriented programming, as it allows the class to initialize the attributes of its instances. So we are creating an instance of this class, and we call this method, and this method is, as it says here, is crucial in object-oriented programming, as it allows the class to initialize the attributes of the instances of the class, of the instances of this class. So each instance of this class is going to have all this initialized, and that's why we call this init method, special method, so we can have all the attributes of the SimpleNet method initialized. Initialize the attributes of all its instances. It refers to the class that the __ init method is in. And so you can see how helpful it is to kind of like just work. You still have to have a little bit of a basic idea of what you are looking for, but you can ask ChatGPT to help you with the process of trying to understand everything. And So here, ChatGPT is saying here is how it works in the context of PyTorch, especially with a class that inherits from the NN.module, and we're talking about this init method. So role of the init method in PyTorch neural network classes. In PyTorch, when you define a class that inherits from the NN module, the init method serves several purposes. Number one, it initializing the superclass. The first and critical call inside the init method of a neural network class is to the initializer of superclass, which is the NN.module. This is done using super.init. This call ensures that all the initialization logic in the base class, which is our NN.module, is properly executed. So this is very important. Once you, in neural networks, once you define this, the special method, def.init, and then you pass in self, then the other one, we call the super. And we are now here talking about the super, and then when we are calling the super, then we are passing in the simple net and also self, and dot underscore init underscore open and close parentheses. So what this line does, that's where we are. This line initializes the superclass. And so it says the first and critical call inside the init method of a neural network class is to the initializer of the superclass. This is done using the super dot underscore init underscore open and close parentheses, and this call ensures that all the initialization logic in the base class, the NN.module, is properly executed. And this logic includes setting up infrastructure needed for the model to keep track of its trainable parameters, hooks, and state. So that's important. Number two, when you define a class that inherits from NN.module, the init method serves in defining layers and parameters. So the init method, this method here, def init, the init method, that method there, the init method is typically used to define various layers and parameters of the neural network. Each layer or component that involves learnable parameters are going to be weights and biases, as we will see later on, must be instantiated in this method. So each layer or component that involves learnable parameters, which are weights and biases, must be instantiated in the init method. And when you see here, for example, layers, linear layers that apply to linear transformation, convolutional layers, dropout layers, and all that. So here we're using the linear layers, and you can see this is where we have our linear layers there. And we also have our ReLU, our linear layer there again. We also have our sigmoid. So we saw that each layer or component that involves learnable parameters, weights, and biases must be instantiated in this method. We'll see more about weights and biases. And then number three, for the init method, the role of the init method in Python neural network is that it sets up other components. So apart from layers, the init method can also be used to set up other components necessary for the network's forward login, such as activation function and pooling layers, although these do not contain parameters. So we have activation function here, the ReLU, and we also have activation function here, the sigmoid. And you can see we have this in the innate method. The point is to try to just understand at a very basic level a simple neural network and what each line essentially does. And I think that's truly helpful, and it helps us to, once we start writing this, writing and coding, we can see how everything is being undertaken, and we can have a basic understanding of how to create a neural network, and then we can build from that basic knowledge. So that's that, and then setting up other components, so that's good. And we saw example of a typical init method that we saw before, and other examples. We talked about the super, we talked about all that. So we truly got a little bit of an understanding of why we have this init method, or we saw an understanding of why. Number one, we inherit from the nn.module, which we saw, and also why we have this method here, this special method called the init method. And also we saw why we call the super, and we also pass in the super, we pass in the simplenet, and also we pass in self. And also, we saw the super, and and then we saw the layers. Although we'll see this a little bit more further with layers, and we'll probably ask ChatGPT to explain to us a little bit further on the layers. But before I go to, maybe I can ask it now actually to explain about the layers. We can ask it about this layer, because we saw the simplenet, we saw the def init method, we saw the super simplenet, and why we need to call it. Now we can see this line here. We can maybe ask it, what does this line do? And as we go, I think it's beautiful. I really think it's a beautiful way to learn that way. And what does this do? And I'll just paste that there. And there we are. We can see what ChatGPT says. So ChatGPT says the line self.layer1 is assigned to nn.linear, then we pass in parentheses 10 and 20 in a PyTorch neural network class is used in a PyTorch neural network class. This is our PyTorch neural network class here, at least part of it where we are defining it. So in a PyTorch neural network class, this line self.layer1 is assigned to nn.layer in open parentheses 10 and 20 in PyTorch neural network class is used to define a linear or fully connected layer as one of the components of the network. So that line is used to define a linear or fully connected layer as one of the components of the network. So remember, here we are defining the architecture of our neural network class, and here this line here is used to define a linear or fully connected layer. So we are defining a layer, we are defining a linear layer. That's why we have linear. A linear layer as one of the components of the network. Remember, we are going to be instantiating this class when we create our neural networks. And so we define whatever, once we start instantiating new models from that class, those models are going to have, they're going to have those linear, the definitions of those linear or fully connected layers. And one of those layers is where we define it here. We define layer 1 as a fully connected layer as one of the components of the network. This statement is specifying the creation of a linear transformation layer, which is one of the basic building blocks of, or rather in, neural networks. This statement is specifying, this statement here, self.layer1 is assigned to nn.linear, open parenthesis 10, comma, 20, close parentheses, is specifying the creation of a linear transformation layer, which is one of the basic building blocks in neural networks, especially in architectures dealing with non-image data, like tabular data, one-dimensional sequences, etc. And then here we have a breakdown of the nn.linear 10, and open parenthesis 10, comma, 20, close parentheses. Functionality. The nn.linear class in PyTorch implements a linear transformation to the incoming data, which is mathematically expressed as that. I won't go into this. I really won't go into mathematics of it. I just want to get a basic understanding of the code, because we're going to be using the code. And but you can see this or that there, but we will pretty much be focusing more on the code as opposed to the mathematics aspect of it. But one thing I want you to understand, as you know, because we've talked about it in our previous videos, is that neural networks, machine learning, deep learning, there's a lot of mathematics that's going on under the hood. And basically, we won't concentrate on the mathematics, but we are going to be relying on PyTorch to be able to implement the mathematics aspects of it when it's training the network. And that's how it actually trains the network, through a lot of mathematics. But we won't be going deep into the mathematics. We are just going to be working with coding and with the code. And parameters. And the parameters of this nn.linear. The first parameter, which is 10 here, specifies the number of input features, and this is the size of each input sample that the layer will process. And we'll see more about the size of input features and how we can put them here as we continue with PyTorch. But the first parameter here, I should actually go here. The first parameter here, this nn.linear, the first parameter 10, specifies the number of input features, and this is the size of each input sample that the layer will process. And then the second parameter, this second parameter here, the 5, this second parameter here, the second parameter, and in this case it was 20 because we used 20 here, but in our case here, in our original neural network, it was 5. But this second parameter, just we have the first one, then the second parameter here when we are defining the neural network nn.linear layer. That second parameter, where were we? The second parameter, where were we? We have to find our way to where we were. So we were there. So the second parameter specifies the number of output features, and this is the size of each output sample that the layer will produce. That the layer, this first layer here, that the layer will produce, this first layer here. So the first parameter, input features. Second parameter is output features in this layer here, the input layer, in the input layer. And then we have weights and biases. Weights, it says weights and biases. So breakdown, and we are in weights and biases. Internally, nn.linear maintains a weight matrix in this case here, because let me just do this. Let me just, so we don't get confused, I will just copy this here and I'll ask ChatGPT to write this in code. Write this in code. And we can, at least so we don't get, you know, so it can be clear when we're talking about 20, we are not saying 5, because we have talked, you know, here we are talking about, we were talking about 20 and we had 5 initially. So I want it to be just like uniform, where we can have 10, 20 when we discuss here, so we don't have things mixed up. So now we have our 20, we have our first parameter as 10 here, and then we also have our second parameter, which specifies the number of output features here as 20. So it can be a little bit more uniform that way. So we don't, it can be very simple to follow, and we don't get lost with the parameters and why they're different. But in any case, weights and biases, internally, the nn.linear, that line that we had, maintains a weight matrix of size 20, 10. See, and we have it here, 2010, 2010 of 2010, output features by input features. I think that's good and important. So we have the output features 2010, 2010. So we start with the output features 2010. So internally, nn.linear maintains a weight matrix of 2010 output features by input features. These weights are initialized randomly at the start and are learned during training. So there's more to this. There's more to what we are doing here. So I think that's beautiful. And also biases. By default, nn.linear also includes a bias vector of 20, which is also learned. You can optionally disable the bias by setting bias is assigned to false if needed. And we'll see this as we continue, but for now I think we're just getting a basic understanding. And so here they were talking about the feed-forward network. So we saw that. Then we can go and ask ChatGPT, what does this line here do? So you just like, I think we're just going to concentrate on the things that we want to learn about, and instead of jumping back and forth and going back to the feed-forward function, we'll just go step by step and just understand each line by line. So I'll ask ChatGPT, what does this do? And we can just continue with our learning. And what is ChatGPT saying? Oh, it's asking me which response I prefer. Oh, that's beautiful. I didn't want it to ask me which response I prefer, but since it has the question, I want the one with code examples. I think or both of them have chat examples. So I want, they all look like almost similar. So usage in a network, neural network, example usage. I'll just say either. I have no preference. So, okay. So this is sometimes ChatGPT, obviously. We'll just have to do it again. What does, yeah, so that's part of machine learning, part of learning with ChatGPT. Sometimes you get ChatGPT getting smarter, and that's okay. Does this do? This do, then I paste that code that I had, and then I press on enter, and there we go. Okay, so I think we continue with our learning journey. Sorry about that, about the different options, but that's what you get sometimes with ChatGPT. So here GPT says the line self.relu is assigned to nn.relu, open and close parentheses, is a Python neural network class that assigns ReLU, or rectified linear unit, activation function to the attribute self.relu. So we are assigning this activation function to self.relu, which we all know because this is an assignment operator. This allows the ReLU function, this is the ReLU function, to be fully used in the network's forward parse to introduce non-linearity into the model. So this, we assign this ReLU, nn.relu, to this, this variable, so we can be able to use the ReLU function in the network's feed forward, in the network's forward parse to introduce non-linearity to the into the model. And ChatGPT provides a little bit of a detailed breakdown of how it functions and also its role in neural networks. But I think this is pretty much a good basic understanding of why we are using the ReLU. And this, as we said, it allows us to introduce non-linearity into the model. And that's the most important thing that you can get from this explanation. The nn.relu helps us to introduce non-linearity into the model. And we have the benefits, characteristics or benefits of ReLU. I won't really go deep into this, but the point is just trying to understand the basic concepts. And here, implementation in the network, when you are using self.relu in the forward method, and this is the forward method here, you see it's def forward. So when you use self.relu in the forward method of your PyTorch model, it applies this activation function here, the ReLU. You see, it says ReLU activation function. So when you use self.relu in the forward method of your PyTorch model, it applies this activation function to the outputs of specific layers, which can be seen in the following hypothetical network structure. So you have the ReLU activation here, that's where we are, and it applies that into the network. You can see here we are applying that into the network. So we are using the ReLU to apply or to introduce non-linearity into the network. And that's essentially what that line does. And I think that's really helpful that's a very good explanation. And so we saw the ReLU. So we have the self.layer1. We saw what that does. We saw the ReLU, the self.ReLU, and what that does. We are assigning that to this ReLU activation function, and so we can be able to use it in the forward method. And then this is another. So we have our first layer here. So we saw our first layer and the different parameters in the first layer, in the first linear layer, and then we saw the ReLU activation function. And then we also, so these are all assignments because we are building a framework. We are building a framework or the architecture of the class that we'll be able to use to build our neural network models. So this is just the skeleton, the architecture, or the framework that we'll be able to use to instantiate models of this simple net, which inherits, as we have seen, from the nn.module. And then we have another layer here. The most important thing that I want you to see, and we'll talk about this a little bit later, but see, this is the input features, the output features, and the output features here in our second layer, the output features here become our input features. We will discuss this as we continue, but I want to just lay the basic understanding, and so we can build from there. So one thing you can learn from here is that always you have the output features here, they go in. What goes out in the linear network, it goes in the next layer. So we have our self.layer2, and it's also a linear layer, and it takes in the 20 which was in the output layers. It takes it in as the input layer, and that's good. So last, I want to ask ChatGPT what this line does, and we'll see what ChatGPT says. What does this do? And then I'll paste that here. And there we are. So it's a very beautiful way to learn, and obviously, as I said, sometimes it's gonna ChatGPT will provide us a lot of information. We just take the information that is helpful for what we want to understand, and then we ignore the deep information that is provided. So here, ChatGPT says the forward method. And this is the forward method here. This is the forward method. So the forward method in PyTorch, nn.module, defines how the input data, which is here x, so it defines how the input data, and the reason it says defines, we are in the class, and we are defining our class. That we are going to be able to use to build our models. And so the forward method in a PyTorch nn.module defines how the input data, x, passes through the network, essentially describing the computation that happens at each layer. So the forward method defines how the input data, which is x in our example here, the input data x, how the input data x passes through the network, essentially describing the computation that happens at each layer. And you can see here, it's defining the computation that happens at each layer. We have x self.layer, apply first layer, and then we pass in the x is assigned to self.ReLUX. So this method here, as you can see, as our ChatGPT says, the forward method in a PyTorch NN.module defines how the input data, which is X, passes through the network, essentially describing the computation that happens at each layer. This is what is known as the forward pass of the network, forward pass of the network. And then we have here is what happens in the forward method of your SimpleNet class, of the SimpleNet class that we created. This SimpleNet class here, of the SimpleNet class. We are now in the forward method, and we are trying to see what happens in our forward method. So number one, input processing. X is assigned to layer 1 X. We build another one here. So X is assigned to layer 1 X here. So X is assigned to self dot layer 1. Also here, X is assigned to self dot layer 1. Then we pass in X, which is the input data, as we said. The input X first goes through the self dot layer. So the input X first goes through the self dot layer, which is a linear transformation. This layer takes an input tensor with 10 features and transforms it with 20 features using a learned weight matrix. And we wanted to keep it, I want to make sure that this is the same as what we are dealing with here. We have this, so we may have to just go back and forth here scrolling, because I think I went to this tab and I forgot to close the, to go with my tab that I was working with. But in any case, so we'll just see here, the forward method in PyTorch NN.module defines how the input data X passes through the network, essentially describing the computation that happens at each layer. This is what is known as forward pass of the network. And here is what happens in the forward method of my SimpleNet class. We are now referring to this class here. I'll just close this because the other class that we created, I think it was different, but in this class here. So number one, input processing, and that is where we have the X is assigned to self dot layer 1 X. The input X, this one here, first goes through self dot layer and layer 1, which is a linear transformation. The self dot layer 1, which is a linear transformation, that's the self.layer 1, which is a linear transformation, first goes through the self.layer 1, which is a linear transformation. This layer takes an input tensor with 10 features and transforms it to a sensor with 20 features using learned weight matrix as bias. So we have here, this first goes, this X, as you can see here, we are having self.layer and then we are passing in X. So this one first goes through this. It first goes through self.layer and with 10 input features and 20 output features, which are tensors. This layer takes the input tensor with 10 features and transforms it to a tensor with 20 features using a learned weight matrix and bias. So this line here, the feed forward method, this line here, we have the self.layer1, which essentially what we are doing is that we are going through, we have the X pass through this linear layer with 10 input features and 20 output features, and transforms it into a tensor of 20 output features using land, weight, matrix, and bias. And then also we have the activation function. We have the X is assigned to self.ReluX, and that is here. We're trying to see what the forward function does. And so after the linear transformation, after this, which gets this to go through this linear layer with 10 input features and 20 output features, we are now here with the relu, self.relu, and that's the activation function. So after the linear transformation, the output is passed through the relu. So we are assigning this X to have this pass through this, and then the output, we are taking the output because this returns the output, and then the output is the one that we are assigning X here. So you see we are assigning X. X is assigned to self.layer1, which goes through this with 10 input features, 20 output features, and then after that, the same X, we now assign it to relu, and that's where we are, and that's the activation function. And so after the linear transformation, the output is passed through the relu, the rectified linear unit activation function, self.relu. So this is where we pass it. So we go here. So this, the output is the output of this X here for the transformation. The output is now passed through the relu function, and this is the relu activation function here. We say self.relu. So that's the relu activation function, and we now pass the X, the output that we got from here. And so we got this one, we assigned the output from here, from this self.layer1X, which is from these 10 input features and 20 output features. We assigned it to X, and then we took that X and assigned it to self.relu, but we also passed the X for relu activation, to activate relu activation. And then after relu activation, we also take that output that we have had with the activation, we have it as X here, and then we also pass it through the output layer, which is here. So we take this self.layer2X, which is here. So this one, it takes in, we pass in X, which takes in 20 inputs, features, and outputs, 2 output features. And the reason we have the 2 output features is because it's a binary classification where we are going to have our cats and dogs. Binary, cat or dog, something like that. So that's what this is saying here. For the X is assigned to self.relu, then we pass in X. That's what it's doing. So after the linear transformation, the output is passed through the relu activation function, and we have a little bit of the relu. It introduces non-linearity to the model, allowing it to learn more complex functions. It does this by setting all negative values in the input tensors to 0. Which can help with issues like the vanishing gradient during training. And we'll see the activation functions. We'll actually see a relu activation function. And I can show you, but I think we'll leave this for another video where we can talk about the activation functions and also draw a graph using matplotlib, draw graphs to see each activation function and how it works. But the most important thing for now is to just know that the ReLU activation function introduces non-linearity to the model, allowing it to learn more complex patterns. That's just the most important thing to learn. And it does this by setting all negative values in the input tensor to 0, which can help with issues like the vanishing gradient during training. And then we have the output calculation. Now we are here, output calculation, because we are there, and output calculation, which is the x, is assigned to self.layer2x. Next, the output from the ReLU activation function, the output that we got from here, and it's x, that's why we have this consistent x. We have x is assigned to self.layer1, and the output for that, we pass it in, and we also have x, we assign that to x, and then we pass it through ReLU, and then the output for that, we also pass it in, and we pass it in by after. We assign it to another x, after, and pass it to layer 2. So we are taking the outputs and passing them to, we are taking the output here, the output from here, and passing it through the ReLU activation. Then we are taking the output from the ReLU activation and pass it in to layer 2. So it's very important. That's why we have x, 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 x here. So just that helps clarify a little bit. So next, the output from the ReLU activation is fed into another linear transformation, self.layer2. And this layer transforms 20 tensors from the ReLU output into 2 tensors. So as you can see, we have the input features as 20, and we have the output features here as 2. So the output from the ReLU activation function is fed into another linear transformation layer, that is the self.layer2, and this layer transforms the 20 features from the 20 feature tensor from ReLU output into a 2 feature tensor. And these 2 features can be used for a variety of texts, for a variety of tasks, such as binary classification, as we are seeing, cat or dog, binary, cat or dog, spam mail or not spam mail, things like that, binary classification. Such as binary classification using a softmax, of the output for the probabilities of each class. We'll see the softmax as we go, or as logits. We'll also see logits as we go in multi-class classification tasks with 2 classes. So the most important thing to understand is that we pass this, we have our x here, and our x, and this is the input data, our x is the input data. Then we have an x here, we assign that x to self.layer1, we pass that input data through self.layer1 with 10 input features and 20 output features, and then we activate the ReLU activation function and passing that data x. So we have x here is assigned to self.ReLU, passing the x output that we got from here, and then we also pass this output from the ReLU activation function to self.layer2, which is going to take in 20 input features, and then give us two output features, which are going to be our binary our binary features that we can be able to use for binary classification, as we have seen here. So that's the output features there. And then we have the return x here, this return x, and the return x here. Finally, the method returns output tensor x, which now contains two values per input instance. This can be interpreted as raw scores or logits to be further processed by the softmax function in a classification task or directly in regression or other types of tasks, depending on the subsequent loss function and the specific use case scenario. Basic, most important thing to understand is that this will return our x, and our x can be used, as we will see a little bit later, we can use this as we continue with the neural network, training as we build our models. But today, I just wanted to introduce you to this concept here, where we build a simple neural network class which is going to provide a framework or provide the architecture from which we can instantiate different models from this class here. So I wanted to just go over the different lines in the class, so at least we can be able to have a basic understanding of what each line is and what it does. And I found it very helpful to do this course using ChatGPT, and I think this is a very beautiful way. I truly think this is a very beautiful way to learn. And as we continue with our PyTorch series, we'll be able to utilize ChatGPT and also get the code from ChatGPT and go to Google Colab, so we can be able to run the code, build the network, train the network, debug, and learn and understand what each action that we are taking as we train and build the neural network, what each action does. I truly think this is super easy and also helps with understanding the basics. I will check out for now, and I will see you in the next video. Thank you very much, friends, and I will see you guys later. Bye bye for now.